For this problem, we have our experiment numbers, and for each experiment we have a different concentration for x and y, and we have the rate determined from it. So what we need to do is isolate certain two experiments to see how the rate changes in respect to one of these reactions, or one of these concentrations. So we want to go to where one of them is held constant and see how much the other changes, and therefore how much the rate changes. So first let's look at x. So y is held constant from experiment 1 to experiment 3. So if we look at experiment 1 to 3, the concentration of x changes from 0.004 to 0.016. So that's a multiplication of 5, or not 5, 4. So we look at our rate and we see that it also changes by a factor of 4. So what that tells us is, since those are the same, is that our reaction is first order to x. So we just have concentration x, and then we look at concentration of y by taking out 3 and just looking at 1 and 2. So we see concentration x is held constant, concentration of y is multiplied by 5. However, the rate changes by a factor of 25. 25 is 5 squared, so we know that y must be second order in the reaction. And now that we have this, we just put its rate constant in front of it, and we get our rate equation, where rate equals k times concentration of x times concentration of y squared.